As you have progressed through your math classes, you've learned different things about right triangles. Let's see if I can focus it a little bit better. There we go. Okay. So when you were in elementary or junior high, that's when you learned that in a right triangle, it was true that a squared plus b squared was equal to c squared, the Pythagorean theorem. But that it was only true for right triangles. So you couldn't use that in any other triangle except a right triangle. But that only helped us find the lengths of the sides. And so last week, what we learned was, and the triangle could be in any direction, it really doesn't matter. If we had a right angle, then we could use Pythagorean theorem to help us find sides, but we also could use our trigonometry, because in relationship to this angle, this side would be opposite, this would be adjacent, and the side that's across from the right one is always the hypotenuse. And so then we talked about our trig ratio. Sine of theta was opposite over hypotenuse, and cosine of theta was adjacent over hypotenuse, and tangent of theta was opposite over adjacent, or SOHCAHTOA. So that also, though, is only true for right triangles. You have to have a right angle or you can't use these trig ratios. So we're still fairly limited, although it is helpful because these trig ratios help us find not only the sides but also the angles. So here we just had a way to find sides. Here we had a way to find sides and angles, but both of these were only for right triangles. So that's where we're moving today. What if we encounter a situation that is not a right triangle? How do we find the sides and the angles then? So that's where our new lesson, the law of sines, comes in. So what this says is that in a triangle, and it can be any triangle, and it can be a right triangle as well, any triangle. So in a triangle ABC, if I draw in the height from one of those angles, and it does not matter which one, then that height is always perpendicular to the other side. This one looks like it bisects. Again, does not have to bisect that side. So it might, but it does not have to. But I'm going to label this side H. Okay, so I'm going to kind of prove the law of sines real quick. So here's what we're going to do. If we were to draw in that height of the original outside triangle here, ABC, I'm going to mark off the right side of this so that all I see is this. In this portion, I could go back, because this is a right angle, because of the height, I could go back and use my right triangle trigonometry. And so the sine of angle A would be the opposite side over the hypotenuse, which is this side. Opposite over hypotenuse. Now, if this is angle C, then this is side C. So the sine of angle A is equivalent to H over C. Same thing is true over here for angle C. If I cover up this side of my triangle, then this is my opposite side, so H. This is my hypotenuse, and in this case, that would be A, lowercase a. So sine of angle C is H over A. So that's where they have come up with these two trig ratios. Okay, so just like we did in our lessons last week, they just multiply by C to get rid of the fraction. So we would have C sine of A equals H. Over here, you'd have A sine of C equals H. Well, if both of those things are equivalent to H, then these two things have to equal each other. So here, they just set them equal to each other. And it gives us a little handy here. It says to divide both of these by AC. Well, if I divide by AC, In this first fraction, the c's divide out. In the second fraction, the a's divide out. And so I have sine of angle A over side A is equal to sine of angle C over side C. It turns out that they are proportional, proportions like you did back in junior high school. So this is very, very easy to use. You don't have to ever, derive it again. But we do need to know that in the law of sines, the sine of angle A over side A is equivalent to the sine of angle B over side B, which is equivalent to sine of angle C over side C. And so remember, just like last week, that no matter what this triangle looks like, if I label this A, B, and C, then angle A and side A are across from each other. Angle B and side B are across from each other. Angle C, side C have to be across from each other. All right? But as long as you keep that clear, then this is very, very easy to do. So here they have a triangle. If you want to draw it, you can. You certainly do not have to draw it, but let me move that up so we can see. But I'll go ahead and draw us a triangle for this one, just for this first one. And again, you can label A, B, and C wherever you would like. Doesn't mean that it's accurate. In this case, obviously not accurate because angle B is 30 degrees. This looks like like an obtuse angle. So, I mean, if you want to make it more accurate, you could do this. It does not matter where you put the letters, is all I'm saying. We could do that if it bothers you and you want the picture to look a little more accurate. So wherever you put those, though, remember that across from them are your lowercase letters. All right, so in this one, angle B is 30 degrees. Angle C is 45 degrees. And side B is 9. All right, so in order to use the law of sines, you have to know an angle and the side across from it. You've got to know one complete ratio. In this case, we know angle B and side B. So I could put sine of angle B, which is 30 degrees, over side B, 9, equals, okay, the other angle that I was given was angle C, so I'm going to use it. So the sine of angle C, 45 degrees, over the side across from it, which is side C. I'm going to make that stem a little longer so it looks like a 9 and not an A. All right, and then you work it just like you would any proportion. We're going to cross multiply and solve. So C times sine of 30 equals 9 times sine of 45. All right, then we're just going to divide by sine of 30. And C equals, oh, hold on just a second. I got to go find my calculator. All right, so on our calculator, we're going to do 9 sine of 45 divided by sine of 30. Be sure whatever calculator you're using that we're in degrees. And so we get 12.728. All right, so now I know side C is 12.728. Now, since we know that ratio now as well, you could use it, but I always caution against that because if you happen to miss this and you use it to find the next piece, then you might miss the next piece as well. So what I'm going to do next is I'm going to go back and use sine of 30 and 9 since those were given to me to find our last ratio here. Now, we have to have one of these two pieces, and right now we don't have either one. We don't have angle A and we don't have side A, but from geometry, we know that in our triangle, we have 180 degrees. So if I subtract the 45 and the 30, then I'm going to get angle A. So angle A is equivalent to 180 minus 45 minus 30. So that should give me, what is that, 105? So angle A here is 105. I'll write that up here. Angle A, 105 degrees. All right, so I'm going to start back again with this same ratio. Sine of 30 degrees over 9 equals sine of 105 over side A. All right, so we're going to cross multiply. A sine of 30 equals 9 sine of 105 divided by sine of 30 divided by sine of 30. So A equals, let's see here, 9 sine of 105 divided by sine of 30. So we get 17.387. All right, so here are our missing pieces. We have side A, side C, and angle A. So that we had 3 pieces given to us. We found the missing 3 pieces. So that's the way most of your homework problems will be. Just be sure that within each ratio, you have at least 1 piece filled in. You can't have an empty ratio of like sine of angle A over side A. You've got to have one of those 2 pieces filled in. And that's it. It's just ratio and proportion. All right, so before I just turn you loose to do your homework on 7-2, I want to show you something real quick. If they were to give you like angle A is 32 degrees and angle B is 48 degrees, and then they tell you that side C is 9. Well, that's 3 pieces of information. So you should have enough information here to use our law of sines, but remember you've got to have a side and an angle across from it. And I have angle A, but not side A. Angle B, but not side B. I have side C, but not angle C. So it seems like that this wouldn't work, but remember your basic trig. If I do 180 minus 32 minus 48, what would that be? Let's see, 50, 80, I get 100 degrees. So angle C is 100 degrees. And then I could use that sine of 100 over 9. That's angle C, and side C would be equal to sine of 32 over side A, for example. And I could keep going. So don't let that throw you when you come to some like that. Use your basic geometry rules too. All the angles in the triangle add up to 180.